Welcome back to another video, and in this video we're going to be continuing on with our core data tutorial series, and in this particular tutorial we are going to be taking a look at how we can set up a core data stack in an iOS application using UIKit. So let's go ahead and get started. The first thing I want you to do is open Xcode. Now I'm using Xcode 16.2, which as of recording is the latest version of this IDE. If you're watching this sometime in the future, it may be 17, 16.4, 18, whatever, but in as of right now, we are using 16.2. So what I want you to do is select iOS as the platform when you create a new project. And then select app as your template. We'll go ahead and just put in a product name. So I'll say test app core data UIKit. And then we're going to make sure storyboard is selected as our interface, not Swift UI. Make sure Swift is selected as our language. Make sure none is selected as our testing system. And then make sure core data is selected as the storage. Now, do not check host in CloudKit. So make sure that checkbox is not checked. All right. Now, I can go ahead and hit next. Right, and then what I want you to do is select a location where you want to store it. So let's see. I want there. I'm going to store it there, and then we'll hit create. All right, now I'm going to make sure that Xcode takes up the entire screen. So we will fill like that. And then what I also want to do is, okay, the inspector is collapsed. That's good. What I want to do now is I want to go into the app delegate. So inside of our navigator, project navigator, I'll say app delegate. Now I'm going to increase the font size here, so we'll say not quite what I wanted. Okay. Of course. I did it Command W too many times. So I can just open that back up. Okay. So I will increase the font size here. Let's see. All right, there we go. Now it's at size 18. Hopefully that's big enough. What I want you to do is we can see here that all of our core data code for the setup is inside of our app delegate, and that isn't an ideal place. So what I want you to do is I want you to find let's see, we want to find our where we have our persistent container being defined. That should be all the way down here at the bottom. I'm gonna go up slightly here. Let's see. Okay, here we are. So we can see we have a lazy variable that's called persistent container. What we want to do is we want to copy this and the function called save. Come on, here we go. So save context. We will cut that. Okay, so we can see we need to have that right there. Okay, so when we paste this in, there's going to be one curly brace that we don't need, so we can get rid of that when we need to. Go ahead and create a new file, and we're going to say Swift file, and we're going to call it data controller. Now, especially in a UIKit and AppKit based application, what I like to do is I like to have all of my core data code in a separate file, and then if it gets too big, separate those operations into their own separate files based on entity. And we'll talk about entities, what they are, when we get to talking about the data models. But inside of this file here, I'm going to get rid of these comments because they're not necessary. And I'm going to add an import for core data. There we go. And then we'll have a class data controller. And we can get rid of that right brace there. We'll paste this in, and because it has an extra curly brace that we didn't intend to copy, it should be fine. Yep, there we go. So let's modify this code slightly, and I'll explain the code as we go. So first we have a lazy var called persistent container. We're going to change this to be called container instead of persistent container. That way it's less code to type. But this is going to, of course, be of type NS persistent container. Now, why is it lazy? Well, it's lazy because we only want to load our persistent container when it's absolutely necessary. That way we can cut down on any load times that are unnecessarily long, perhaps. So now I'm going to get rid of the comment here that we have. There we go. Now, here's the thing about our persistent container code that we have here. I'm gonna put a new line in between that just so it looks nicer. We have a object called container, right? So let container equals ns persistent container, and this takes in a name. Now, the name that it's being given is the name of our data model. Again, we'll talk more about data models when we get to them, but pretty much the data model is just the thing that core data uses to generate the actual underlying database. Now, after we actually create that object, we need to load the persistent stores. And we can see that this call takes in a completion handler. And inside of this completion handler, there are two parameters that it takes. The store description, which is of type ns store description. It pretty much it's basically an object meant to describe the persistent store. And then there's an error parameter. Now, this parameter, the error parameter, is optional. And the reason why it's optional is because there are certain things that could happen that can go wrong. So the error has to be able to flip between nil and non-nil values. If it's nil, right? If error is nil, we know everything went okay. But if it's not, we know something went wrong. Like maybe we don't have write permissions. Maybe the parent directory doesn't exist. Maybe there's not enough storage. Stuff like that can cause the load persistent stores to fail. So that's why inside of the completion handler closure here, we are testing to see if error is nil or not, and then storing it in its own constant as an ns error. And again, the reason why ns error here is optional, just like error in our completion handler, is because we don't know if this is going to be nil or not. So error is going to be optional. Therefore, when we cast it to an ns error, it also has to be optional. Now, you might be looking at this code and thinking, wait, why isn't there a question mark or an exclamation point when using the as keyword? And that is for one very specific reason. The Swift error type is directly bridged under the hood to the Objective-C NS error type. So that's where we get NS error from. We get it from Objective-C, which is what, of course, core data was originally built with. It's originally an Objective-C framework. So we have to work with some Objective-C APIs through Swift, which is frankly not very pleasant some of the time, but it is what it is. But in the if-let here, we're just casting that Swift error that we get to an NS error. And then if there is an error, we are simply calling fatal error to force a crash. Now, of course, fatal error here might be okay, but in most cases, it still isn't going to be necessarily the best of ideas. you do you do want to make sure that your user knows, hey, we don't have enough storage, right, to do anything in, or hey, we don't have a parent directory for this, or just let them know that something went wrong. That way the user doesn't see the app crash and think, wait, something wrong with my phone? Is the app buggy? That kind of thing. You should always um, you should always opt for informing the user of what went wrong rather than just crashing the app and not saying anything. So I'm going to also get rid of these comments. Okay, there we go. And then after we've made sure that everything works fine, we're simply returning the container for our lazy variable. Now, we have a method called save context. I'm going to modify this to just be save. So that way, again, it's less code to type. Now, here we are retrieving our managed object context from the persistent container. The persistence container stores our managed object context in an object called view context. Make sure that this is changed to container. So let context equals container.viewContext. I'm going to add a line in there to make it look nicer. And then the first thing that we're doing is we are seeing whether or not our managed object context has any changes. Now, why are we doing that? Well, we're doing that because if there aren't any unsaved changes in our context, it wouldn't be worth it to do saving, right? There would be nothing to save, therefore we're doing work that is wholly unnecessary. So we only want to actually perform a save when there's saving to be done. And that's what we're doing here. And then again, because the save method on the managed object context can throw an error because maybe something went wrong, like we can't save the data because there's not enough space, or just our core data failed to save it for whatever other reason there might be. Right here we're forcing a crash, but again, you probably shouldn't do that in a real world app. You should always let the user know that when something goes wrong. All right, and then again, inside of the catch, we're also converting the error that we get back to an NS error, and then printing out necessary information when we cause the crash. And really, that's about it for the core data setup of a UIKit application. When we save this and we try to run our code, we do get a build failure. So if we look in our issue navigator, we can see that we get an error, and that's because in our app delegate, we're trying to save changes when our app enters the background. So what we'll do here is in our scene delegate up top. We'll have a let data controller equals data controller, and then down where we are trying to save our context changes, instead of trying to get our save context method from our app delegate, we can simply say data controller.save. All right, there we go. We can save this and run our code. And now we get a successful build. And let's see. It should run successfully in a simulator or on your own device. Of course, it wants to run on my device, but what we're going to do here is I'm going to change the run destination. We'll have it run on the 16 Pro Max. All right, we have a successful build. And we're not going to see anything because we don't have any, anything in the user interface. It's just a blank view controller. But we have successfully set up our core data stack. So with that pretty much does it for this video on how we can set up core data in a UIKit based application. Thank you all so very much for watching, and we'll see you in the next video.